Mindsetters, welcome to today's grade 11 maths show. Today we have a special revision lesson on quadratic equations. We have selected highlights of lessons shown earlier in the term to help you revise term 1's work. Please post all your questions and comments on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision. Don't forget to download today's show notes on learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with our lesson.
The first note that I want to draw your attention to is that the word solutions of an equation has got a synonym, are also known as, what are the solutions of an equation known as? Who has worked with that before? Why don't you just send AB that answer, and we'll look at the end of the segment. We'll see who's got the synonym for solutions. Let's see who's the right one this afternoon. Okay, so while you're doing that, finding a synonym for solutions, we're going to start off by completing the square on this equation. And we need to leave our answer in simplified third form. So if you're completing the square, the one factor that involves getting it correct is that the coefficient of x squared must be 1. So if I look at the current coefficient, it's -2. So I'm therefore going to divide by -2 on both sides. And so I get x squared minus 6x plus 4 is equal to 0. Let's just check that. That's negative 2x squared, positive 12x, and negative 8 is equal to 0. Once you've got the coefficient of x squared as 1, we're now going to take just the binomial. So we're going to take, what are these little things doing here? Where do they come from? Right, so we're going to take just the square term and the linear term, and the constant, we're going to take it, we're going to eliminate it. So we're going to get rid of it by adding -4 to both sides. Now, the next step is where the completing of the square comes from. We're going to add a constant to our quadratic. And the portion that we're going to add is half the coefficient of x, and we're going to square it. So if I take half of -6, that's -3, and if I square it, I'm going to get +9. And this is an equation, there's an equal sign. So what I do to the left, I do to the right. So coefficient of x squared is 1. And then this is where the portion where I complete the square. In other words, I'm trying to get the trinomial to become a perfect square. And the way that it becomes a perfect square is if I add half the coefficient of x and I square it. So now I have got this trinomial, x squared minus 6x plus 9. Grade 11s, I'm saying completing the square because ultimately that trinomial must be factorizable. It must factorize into a binomial that is squared. It better, otherwise we are wasting our time here. So it factorizes as x minus 3, and we're squaring it. Does it work? -3x, -3x is -6, and -3 times -3 is +9. So that's equal to 5. Okay, once I've got my squared value, I now have this situation where if I take the root on the left, I get -3. Or if I take x minus 3, I can equate it to, if I take the root on this side and the root on that side, I'm getting √5, but I could also get -√5. So this is something that you brought from grade 10, and that is that if you've got x squared is equal to 4, let's look at a perfect square example, then the quadratic equation has two solutions. It can be 2 or it can be minus 2. Because if I substitute 2 and I square it, I get 4. I substitute negative 2 into my quadratic, I also get 4. So a quadratic has got a possibility of two solutions, one a positive, one a negative. So I'm doing the same thing, but because I've got a non-perfect square, I've got 5, I'm going to look at x minus 3 is 5 or x minus 3 is negative root 5. And then to end it off, I can now solve for x and say that it's 3 plus root 5 or x equals to 3 minus root 5. Okay, and I would really only do that if I was asked in the instruction to complete the square. Otherwise, I know that this method is there to help us prove the quadratic formula, but I wouldn't ordinarily use it. I would stick with the quadratic formula. It gets to the solution much quicker. Okay, so just to recap, if you do not make the coefficient of x squared 1, you are stuck. You can't go anywhere. So that's what we did first. Coefficient of x squared is 1. Then we've added the most important part, this green portion. We've added half of negative 6, which is negative 3, and we've squared it, so we've multiplied by itself, which is 9, but we don't want to unbalance the equation. So if we had to take away the 9, we would still be getting the same equation. It's still equivalent. And once we've done that, we can now factorize into the binomial squared. So at this stage over here, we have factorized into, why do we say that this is a perfect square? Because it's made up of two factors that are the same. They're exactly the same. So x minus 3 times x minus 3, it will give you the area of a square, and your area of the square is x squared minus 6x plus 9. Okay, and then you can just solve for the x once you've taken both sets of solutions. All right. So that is completing the square in a nutshell. Now,
okay, Dina, before
yes.
you move on that question, I seem to be having some questions from the mindsetters.
Yes.
They say, why did you plus the 9y? Don't you just divide by 2 both sides?
We did divide. Let's go over it.
And others say, why don't you divide by minus 2 both sides?
We did divide by minus 2 on both sides. If you look here, you've got 0 divided by negative 2 is still 0. So we did do that. Grade 11s, we've divided everything by negative 2. We've divided that term by negative 2, we get x squared. We divided that term by negative 2, we get negative 6x. We've divided negative 8 by negative 2, we get positive 4. And we've divided 0 by negative 2. And 0 divided by negative 2 is still 0. So we have divided.
And quickly, one last more. How did you get your 9?
Okay, I've set it in the green block, and I've made it green so we can see how we did it. I've taken a half of the coefficient of x. So if you look at the x term, its coefficient is negative 6. So I've taken the negative 6. Let's just put it in nicely over here. So we've taken a half of negative 6 and we've squared it. So that's negative 3, which we have squared, which is 9. So the green portion is exactly what we've done. Okay. Yeah, I'm glad that you're asking because it really is a foreign concept. You haven't done anything like this before. So it's important to just go over it and consolidate to make sure that you really got it. So it's great for those questions. All right, now if you look at this equation, 2x cubed minus 5x squared minus 11x equals 0, that's a very interesting question because I've been talking to you about quadratic. And the word quadratic in English may mean nothing to you because this word comes from the root, the Latin root quadra, and the quadra is actually a square. In some of the European language, you say a quadrado, and that is a square. So for those in the world that have got Latin as its root word, the quadratic equation really means something. They can identify with a square, in other words, that power of 2. But for us in South Africa, where the language doesn't really build up from the Latin, you really have to really memorize and make it part of your bloodstream, that a quadratic equation means that the highest power is 2. The moment I come to this equation, the highest power is not 2. The highest power is 3. So what are we going to do with it? Well, we do what we do with all nonlinears. We try and see if it's factorizable. So I look at all 3 terms and I ask myself, is there a common factor in all these 3 terms? Yes, there is. There is an x. So I'm left with a 2x squared minus a 5x minus 11 is equal to 0. So now I'm landing with a very interesting trinomial here, plus I'm landing up with this factor. Now remember, in our notes we said that if you have an a times a b times a c and you're equating it to 0, then it means that a is 0, or maybe you can have b as 0, or you can have c as 0. What we don't want to do is we don't want to take a term onto that side, because then it makes it impossible to solve. Then we've got no way of being able to solve. So we now have this factor times that factor, so we've got x can be 0. And it's true, isn't it, that x can be 0, because 0 minus 0 minus 0 give me 0. So x can be 0. Or we've got 2x squared minus 5x minus 11. So we've got a really interesting case here of whether this particular quadratic is this factorizable. And some of you may say, well, yes, you think that 11 and 2 will factorize. Well, I'm beginning to doubt whether it does factorize. So because I'm doubting myself, I'm going to automatically use the formula. But before you do that, what is a? A will always be the coefficient of the x squared. B will be the coefficient of x. And c will be anything that's not attached to the x squared or the x, which in this case is minus 11. And now I will use the formula, write it down every time as negative b. You can have the positive or the negative of this square root, b squared minus 4ac, and you're dividing everything by 2a. And now we can substitute. B is negative 5, and in other words, we've got a negative 5 squared minus a 4 times an a, which is now a 2, and the c, which is negative 11. And we're dividing that by 2 times 2. So all I've done is I've substituted those ABC values into the formula, and simply because I want to illustrate that if you're not sure if it's factorizable, you can go ahead and just replace the coefficients, and it gets us to this. Plus or minus the square root of 25 plus 88. So it looks like it's 113 if you check my arithmetic. So we've got 25 and 88, 113. And that really is the 2x values. Now notice that there are 2 x values inside here. There's an x of 5 plus that root over 4, or there's an x equals 5 minus that root over 4. So there are actually 2 values. And we've got the other one that we've left behind because it was so quick. It took us so quickly to find out, and that is that x can be 0, or x can be those 2 values as well. So that cubic actually has 3 solutions, and that's the maximum number that a cubic can have. Now notice, the quadratic, because it's square, it doesn't have 3 solutions. It only has maximum of 2.
Alright, Mindsetters, I hope you guys are enjoying this revision session. Remember, if you are struggling and need help, please post your question on our Facebook page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, so don't go anywhere. We'll be right back. Welcome back, guys. I'm sure you've seen and heard about the Mindset Rack nomination and hope you'll get involved. If you make a video, post it on YouTube with the title #LearnExtraRack followed by your name or the name of your group. If you don't have a video, post a photo on our Facebook page and tell us what you've done. Let's use this short holiday to make a big difference in other people's lives. Now, let's get back to revision.
What I really like about this question is it's got the quadratic and grade 11s. It's got what else? An exponential equation. But because you've been watching Mindset, you have been up to date with the exponential work, and you'll know that when we're solving for an unknown exponent, that we've got to get the bases to become the same base on either side. Same base. So we're not even going to touch the quadratic. We're going to rather look at the exponential and say, if we have a 2 to the x, that's saying the same thing as 2 to the 2y minus 6. And because the bases are the same on either side of that equal sign, we therefore can equate just the exponents. X equals 2y minus 6. Aha! Now I have been able to create my linear. So my linear was there, but it was hiding. And that's what happens sometimes. Remember in the notes we said, you look, you focus on the linear, and you take that linear and you substitute into the quadratic. Well, here, it was there, but it was hiding underneath an exponential equation. Okay, so that would be my first equation. This equation over here would be my second equation, and I'm going to substitute 1 into equation 2. So then I get x is 2y minus 6 squared plus y squared equals 20. And now we're going to keep pressing with our algebra. Grade 11s, this is a binomial squared. Remember to square the first. Outers and inners, what are they? Negative 24y. And square the last, plus 36, plus y squared equals 20. So we've got a 5y squared plus a 24y. 36 minus 20 is plus 16 is equal to 0. Okay, so what are my factors? I'm assuming this factorizes. 5 and 1, and 16 is an 8 and a true. So that doesn't quite do it. So maybe a 4 and a 4. That's 20. Yes, that's much better because that's 20 and that's 4. Great. So we've got a 5 and a 1. And we've got a 4 and a 4. So we don't really have to think about this. And if we carry on, y is minus 4/5, or y equals negative 4. How many are still with us? Grade 11s? Happy? So x is then, let's see what x was. X was 2y minus 6. 2y minus 6. Or x is 2y minus 6. So we've got a negative 8/5 minus 30. So it's minus 38/5. Or x equals to minus 8 minus 6 is minus 14. Okay, so when x is negative 38/5, y will be that, and when x is negative 14, y will be that.
I'm sure you've seen the walk together photo on our page. Please post a caption and like the captions that you think are best. The 3 captions with the most likes will each win a pair of tummy tackies. We'll post the winners on Friday, so get to liking and get all your friends to like too. Now it's time to take a break, so don't go away. We'll be right back. Welcome back, Mindsetters. Today we are doing revision. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra or post or comment on our Facebook page, facebook.com/LearnExtra. Right now, let's do some more revision.
Great, well, welcome back. We are going to now look at some questions which are going to use all 3 of the aspects we've discussed in our summary. So let's start with the first one, and this one's going to give you a little taste of how we ask you the number systems before we actually get into the nature of roots. Let's have a look. It says if x is an element of 0, 1, 2, 3, 4, and 5, determine the value or values. When they do this, what they're trying to say to you is there won't just be one answer. There might be for one or two of the questions, but mostly there will be more than one answer. Otherwise, they won't use that little bracket with values. Of x, for which the expression, and there's the expression, is not defined. Now, I did mention not defined when we were looking at rational numbers. I said to you, a rational number can be written as a over b, where b is not equal to 0, because if b is 0, the whole thing is undefined. Okay, so if we go over there, and I look at this expression I've got, let's make it nice and big. It's 9 over 4 minus x. The only way I'm going to get not defined is for my denominator, which is this guy here, to equal 0. Now, if that happens, if 4 minus x must equal 0, you agree with me, that doesn't matter about the numerator. Numerator is not going to make it not defined. It means that the 4 equals x. Now, what I need to do is go and see, is 4 in my set? Yes, there it is. So that's fine. I can answer it, x equals 4. Now, remember I said to you, they do this because sometimes there's more than one answer. Well, this one so happens to be the one where there is only one answer. Right, the next thing they want to know is for what values is this expression rational? Now, quite honestly, we know that 4 is undefined, so all we'd have to do is use the other values and see what they look like. So let's get hold of them. Okay, so if we start at x equals 0, this would become the square root of 9 over 4 minus 0, which is equal to the square root of 9 over 4. And of course, that's good news because both of them are perfect squares, so we're going to get 3 over 2. Asking you this question, 3 over 2, would it be rational? Yes, it would, because it's written as a fraction, and both of them, the denominator is not 0, both of them are integers. So this is definitely rational. So that's my first answer for this one. So I can say x an element of 0. Right, let's try the next one, x equals 1. If I'm taking 1, it's going to be 9 over 4 minus 1, which is equal to the square root of 9 over 3, which is the root of 3. What do we know about the root of 3? Well, 3 is not a perfect square. So if it's not a perfect square, it certainly is not rational. In fact, it must be irrational. So what I can do now is I can do this, not q. Right, let's look at the next value for x. X equals 2. And now it becomes the square root of 9 over 4 minus 2, which is the square root of 9 over 2. Problem, the 9 is a perfect square, but the 2 is not. So we have again an irrational answer. Right, the next one. If x is 3, we have the square root of 9 over 4 minus 3, which of course is the square root of 9 over 1, which is incredibly good news because it's just the square root of 9. And the square root of 9 is 3, and 3 is just a good old-fashioned integer, whole number, natural, whatever you want to call it, so it certainly is rational. Right, now I think we only had to go as far as 5. Yes. 4 we've already done. We know that 4 is not defined. So I'm just going to put it here. And so the only one left to check is x equals 5. So of course you can do this very quickly in your exam or test. I'm showing you all the steps so you can see how it's done. That becomes the square root of 9 over negative 1, which is the square root of negative 9. Now we know when that happens that we are dealing with non-real numbers. So real would look like this. Not real would have a little dash on it like we do with rationals and irrationals. Right, so let's go back to the question. The question said, what values make it rational? Well, certainly 0 did, and 3 did. Everything else did not. So those are the only two answers I can have there. And then irrational, well, when I look at what was irrational, it was this one, the 1, and the 2, and I don't think any of the others. So the answer here would be x, an element of, in fact, I think I must write it on the side here. X, an element of, was it 2 and 3? I think it was. Yeah. No, wait, let me just check. 1 and 2. And then it gave you the wrong values. So let's just clear up a little bit here. Okay. So 0 made it rational, 1 made it irrational, 2 made it irrational, 3 made it rational, 4 was not defined, and 5 was non-real. So in a little question like this, I've managed to check whether you understand your number systems. So it's just a little taste of how it would be asked, and it gives you an idea of how we can sort of get to whether you understand the concepts or not. Right, let's look at question 2. Now, this is much more the nature of root kind of questions. The first one there says, determine the nature of the roots of each of the following without solving the equation. Without solving the equation. In other words, you can't just go and factorize it or use the formula or complete the square. They want you to use that theory we had just now, that third bunch of theory. So what I would do is I'd start first of all by looking at these equations. Let's take A. It's x squared equals 5x minus 4. Now we know that we have to get it into the form of ax squared plus bx plus c equals 0 before we would even try to use anything, because we need to have the right signs on our a, b's and c's. So the first thing I'm going to do is write this as x squared minus 5x plus 4 equals 0, which means my a value is going to be 1, my b value is minus 5, and my c value is 4. Right, so the delta value, the discriminant value, is b squared, so it's minus 5 squared, 4 times the a, which is 1, times the c, which is 4. Right, so minus 5 squared is going to be 25, and minus 4 times 1 times 4 is going to be minus 16, which is going to give me 9. Now, if we think back to our theory, if delta was greater than 0, we knew the roots were real. Then the next thing we would have had to decide, does this make it rational or irrational? So remember, the delta goes inside the square root sign. So 9 inside a square root sign will be no trouble because the square root of 9 is 3. So that makes it rational. So really I can tell them the roots will be real, they will be rational, and they will be unequal, or you could say different. Okay, really it doesn't matter which word you use there, but probably if you got it in a test, they might use the word unequal. So just get used to thinking unequal, different is the same thing. So what does that mean? That means if I factorize this, I would get 2 real answers that could be written as fractions, and they would be different answers, not the same answer. Right, so let's go to the next one. The next one gets a little bit more exciting. It's now got a little bit of action you've got to do first of all. Remember what I said to you, it's very important we work it into this form before we start. So let's just get some space here. I don't want to move too much off where we are so we can see what's going on. So let's take a green pen. There we have it. We want to get it to look like that. So the first thing I'm going to do is I'm going to multiply this out. Okay, and if I do that, x times x is x squared. Then if I times x by 2, I get plus 2x minus 3x minus 6 equals 3x plus 6. Now remember, the idea is to get everything on one side, so let's leave the x squared there. Let's bring that over, and it was a plus 3x, so it's going to come over as a minus 3x. So I have 2, minus 3 is minus 1, minus another 3 is minus 4. And over here I've got minus 6, and I'm going to bring that minus 6 over, so it's minus 12 equals 0. So now I've got it in that form, which is good news, because the next thing I'm going to do is I'm going to go and work out my discriminant or my delta value. Okay, so I don't have to even show them what A, B, and C is. It's absolutely fine to just do the substitution. So I suggest while you get used to it, you do it. But once you know, just go straight to this. So your B value is minus 4 squared. 4 times your A, which is 1, times your C, which is minus 12. Just a little warning, be careful not to forget your sign. Whatever the sign was in front of the number must go with the number when we substitute. So now once we're here, we're going to say minus 4 squared is 16, and a minus times a minus is a plus, and 4 times 12 is 48. And if we add that, we're going to get 64. Now that's very good news, because remember, that's the inside of the square root sign. So if that's the case, do we have a square root of 64? And hopefully you all can recognize that. So it's real, it's rational, and it's unequal or different. Now, basically, when you do get a perfect square there, that means you could have just factorized it normally. So sometimes this is a useful thing to know when you're getting a quadratic equation. You look at it and you think, I don't know if this thing factorizes. So if you work out the b squared minus 4ac and it gives you 0 or a perfect square, you can factorize your question. Right, so that was very similar to the first one. Let's see if the last one's a bit different. And yes, it is. First of all, it's the way it's represented. Now remember what I said to you, we have to show it that we can see it in the ax squared plus bx plus c form. Oh dear, put that on again. Okay, so the first thing I'm going to do is get it into the correct form. So the first thing I have to do in this case is times both sides by the common denominator. So what's going to happen is I've got the top of that expression, and I'm multiplying by this across the equal sign. So it's 4x squared minus 2x plus 1. And now we're going to tidy it up. So it's 4x squared plus 2x plus 1 equals 8x squared minus 4x plus 2. Right, now remember, the idea is to get everything on one side. And just because I'm thinking conveniently, I'd rather move this way so I don't get a negative x squared. It really doesn't matter if you do. It's just convenient. So 8x squared minus 4x squared is 4x squared. Minus 4x minus 2x is minus 6x. And plus 2 minus 1 is plus 1. All right, good. So what does that mean? We now have it in the right form, so we can work out our delta value. So delta is b squared minus 4 times a times c. And if we work that out, it's going to be 36 minus 16, which gives me 20. Now remember, the 20 is under the square root sign. Is 20 a perfect square? Hopefully we know it's not. So that means it will be real. It won't be rational anymore. It will now be irrational. And it will be different because obviously you're going to get two different answers if you add root 20 or you subtract root 20. So if you were going to tell me about these roots, you could say they are real, they are irrational, and they are unequal. Okay, so I think that is a little taste of what they would be finding quite useful for you at this stage. Let's look at the next question. Right, this one's quite nice. They say if b squared minus 4ac is 7k squared. Now remember, that means the delta is 7k squared. Determine the nature of the roots if k is 0. Now that's nice. You know it's equal to 7k squared, and they've told you k is 0. So that's a nice little question. So delta would become 7 times 0 squared, which is 7 times 0, which is 0. Now what do we know? If that's the case, the roots are real, they are rational, and they are equal. All right, good. So now the next one says, what would happen if k was the root of 7? So now your delta is 7, the root of 7 squared. Now hopefully you're okay with this, but what I'll do is do a little bit of a method. So that would become root 7 times root 7, which is 7, and that will become the root of 49, because you can times the roots inside together, which is 7 times 7, which is 49. Now, if delta is 49, what do we know about the roots? Well, they are real. This time, they are rational, because 49 is a perfect square. but they are not equal, because if it's going to be 49, they will be unequal, because the one hand you will take plus 7, on the other hand you will take minus 7. So I think it's quite clear to see how that one works. So that's a nice way to ask it too. So I tell you something, I give you some kind of format, and I ask you questions. I suppose I could even be a little bit more shrewd than that. I could have said to you with this question, let's give some more space, change color pen. So let's say I said to you the delta is equal to 7k squared. And I could say if k is a real number, what type of roots would we have here? Well, if it's a real number and you're squaring it, you're going to get a perfect square, or at very worst a 0. So straight away you know that the answer would be real no matter what. And of course you saw that when we worked it out. Then, because it's either 0 or perfect square, it would be rational. But is it really? I've just realized that not necessarily. It could be either of those. Because if this, that it worked out fine in this one, because the root 7 times root 7 gave you a 7. So you would have ended up with a perfect square, but you could have got something that wasn't a perfect square. And of course, if it was rational, it could have been unequal or equal. So really, it's not such a nice question because there's too many options. The only thing we could say for sure is that the roots would be real. Okay, so let's look at another example. I think we might have to go to break shortly, but let's see how we can, even if we just introduce the question. This one says, calculate the values of p for which this equation has real roots. So this time, they're telling me what the roots are like. What they're doing that's different is they're not telling me what p is, because they're saying find the values of p where the roots will be real. All right, so let's quickly see how we can go. It is in the right form. Our a is equal to 2p, our b is equal to minus 4, and our c is equal to 3. So our delta value would be minus 4 squared, 4 times the a, which is 2p, times the c, which is 3. Now, that's equal to 16, and 4 times 2 is 8, and 8 times 3 is 24p. But they told me it has real roots. So if we go back to our first slide where we had our summary, let's just go back there, we would have seen that in order to get real, and it does help if one can get this to slide down, to get real, we need to have this option or this option. The only time they're not real is when it's less than 0. So what I can do now, back to the question, okay, sorry, I just went a little bit too far. If I look at the question here, basically what I would know, and I don't know why this is not behaving nicely for me. Okay, we know that this would be greater than 0. So 16 minus 24p is greater than or equal to 0. And it would just be a matter of solving this. Okay, so I'm not going to go too much further. We can maybe look back at this one later on. But this gives you a bit of an idea of what we've got. So p would be less than equal to 2/3. Sorry, Looney, I think I got carried away there.
I think it's time for a break now. Don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and for the holidays to start. This year we bring you revision sessions from term 1 from the 28th of March till the 6th of April. These will be repeats of all the Learn Extra live shows from term 1. These programs will run from 9 a.m. in the morning till 7 p.m. at night. Go to our website learn.mindset.co.za for all the details. But for now, let's get back to the revision.
Let's look at the first question. I'll be very slow. The following sequence of numbers forms a quadratic sequence. Now, the minute they tell us that this is a quadratic sequence, so we know that the second difference is constant. Okay? Now, it is minus 2, minus 3, minus 6, minus 11. Find an expression for the nth term of the quadratic sequence. So we need to work out what Tn is here. Okay? Right? Explain why the sequence of numbers will never contain a positive term. All right. Now, this is a sequence, -2, -3, -6, -11. Let's work out the differences. We know that when we're getting the first difference, okay, our difference will be term number 2 minus term number 1, term 3 minus term 2, term 4 minus term 3, term 50 minus term 49. Right? So now, here I've got -3 minus -2, which is the same as saying -3 plus 2. So we get -1 here. Okay? Now, the next one, we've got -6 minus -3, which simply means that we have -6 plus 3, because a negative times a negative gives us a positive. So -6 plus 3, we get a -3. Next, -11 minus -6. So you've got -11 plus 6, which gives us -5. Okay, so now we're looking at this first difference. It's not the same throughout. So we've got -1, -3, and -5. So it's not constant. So that is not linear. We're not having an arithmetic sequence there. Now we go and look for the second difference. Now the second difference, you've got -3 minus -1. So we simply say is -3 plus 1. You get a -2. Okay? And then -5 minus -3, which is -5 plus 3, then we get a -2. So our second difference is constant throughout. Now, we said this sequence is in a form Tn equals to an squared plus bn plus c. And if we sub in 1, we get the first term, which now gives us a plus b plus c. Now, let me write that next to this, okay? Now, our term 1 will be, sorry, just get this out. This will be a plus b plus c. Because we have Tn equals to an squared plus bn plus c, you put a 1, you get to term 1 will be a plus b plus c. Right, now, our first term of the first difference, we said this gives us your 3a plus b. Okay? Now, our second difference, we said this is 2a. Right? Now, I have 2a equals to -2. I need to get it in this form, Tn equals to an squared plus bn plus c. So now my main aim is to get what the value of a is, your b, and your c. All right? Here, I've got 2a equals to -2. Therefore, a is -1. So I have a equals to -1. I need to work out what b is and what c is. Now, if I go up a bit, I know that this is my first equation. I know that 3a plus b will be equals to my first difference, which is -2. Right? But I already know the value of a, that a is -1. So I can sub in the place of a. So I have now substitute this a into this equation, which we can call it equation number 2. So substitute 1 into 2, so you get -1 plus b is -2. So therefore, b will be equals to 1. So because you've got -2 plus 3. I've got a, I've got b, and I need to work out what c is. Now, I go up. I know that the first term will be a plus b plus c, which will give me -2. So I know that a plus b plus c, it's -2. Now watch, guys. We already know the value of a. We know what b is. We'll be remaining with only one unknown, okay? So a is -1, b is 1, plus c equals to -2. So now -1 plus 1 is 0. Therefore, c is -2. So our formula, therefore, is Tn equals to an squared plus bn plus c, which is Tn equals to A is minus 1, so it's minus n squared, and B is 1, so plus n, C is minus 2. All right? Now, guys, how do you check if you're correct or not? This is your Tn equals to minus n squared plus n minus 2. If you sub in 1, you will have minus 1 plus 1, which is 0. You left with minus 2, which in this case works out because your first term is minus 2. Now you go on, if you sub in the place of n, sub in 2, you get minus 4 plus 2 minus 2, which gives us negative, sorry. If you put 2 there, you get minus 2 squared, which is 4 plus, that's negative 4 plus 2 minus 2. We might have made a minor mistake there at the top. So you've got your 3a plus b. That looks fine. Okay, we'll confirm that just now. I showed you another formula here that your Tn equals to T1 plus n minus 1 f plus n minus 1 bracket n minus 2 divided by 2 times s. And we said in this formula, your T1 is your first term of the original sequence, and in this case, your first term is negative 2, right? So you've got, this is negative 2 plus n minus 1. Your f is the first term of the first difference. So you've got minus 3 minus minus 2, which is negative 1. So you sub in minus 1 here. Then you get, this is n minus 1, n minus 2, which gives us n squared minus 3n plus 2, all divided by 2, times your s. So the s is your second difference, which is minus 2. So your second difference is negative 2. Then you simplify, so you get minus 2 minus n plus 2 plus, now this will give you a minus 1 here, bracket n squared minus 3n plus 2, which is now minus n squared plus 3n minus 2. And your final answer is minus n squared plus 2n minus 2. Now, if you check, if you put a 1 here, you get minus 1 plus 2, then your final answer will be your minus 2. Now, if we move on and we need to explain why the sequence of numbers will never contain a positive, our second difference is negative, okay? Our second difference is negative, and we're starting with a negative number, so we're starting with minus 2. So the second difference is minus 2, and we're starting with the first term, which is a negative, and if you add, you keep on adding a minus, then all your terms will be negative throughout, all right? So now, let us move on to the next question. Now, question number 2, if you didn't get the first one, let's just listen to the second one, all right? Find the formula for the nth term of the sequence. Now, work out the differences first. So what you do is, you've got minus 1 minus minus 3, you get positive 2, because you have minus 1 minus minus 3, and that's minus 1 plus 3, and the answer is 2. So you've got 2. Now, 3 minus minus 1, you get a 4, and then the next one, it's 9 minus 3, you get a 6. So the first difference is not the same, right? So now, you go on to the second difference. 4 minus 2 is 2, and then 6 minus 4 is 2. Now, just want to go a bit slow here. If you want to be accurate, so you circle the first letters, so the first numbers. So the first term will be your T1. The first term of the first difference will be your F, and your second difference will be S. And the formula is Tn equals to T1 plus n minus 1 F plus n minus 1 n minus 2 divided by 2 times S. And now the only thing that I'm left with doing is to substitute. Term 1 is negative 3 plus n minus 1. The F is 2 plus, if you multiply out this, you get n squared minus 3n plus 2, all divided by 2, times s is 2. Now the 2 and the 2 divides. So next, you have minus 3 plus 2n minus 2 plus n squared minus 3n plus 2. All right? Now, you collect like terms. You've got n squared minus n and that minus 3. So your Tn is n squared minus n minus 3. Okay? Now, how do you check if this is correct or not? You say now, term 1 will be 1 squared minus 1 minus 3, which gives us a negative 3, right? You go and check, your first term is negative 3. You go on and say, term number 2 is 2 squared minus 2 minus 3, which gives us 4 minus 2, that's 2 minus 3, that's negative 1. Now, if you look at your original sequence, you've got a minus 1 there. Now, term number 3 will be 3 squared minus 3, which gives us 9 minus 6, and we get a 3. Term 4 will be 4 squared minus 4 minus 3, which is 16 minus 4. You got 16 minus 4, which is 12 minus 3. You get a 9. So the sequence is minus 3, minus 1, 3, and 9. Okay, I hope that helps. Now, those of you who are going that other route of saying Tn equals to an squared plus bn plus c, you have your second difference, which is 2. Now, watch. You have a sequence which is negative 3, negative 1, 3, 9. Let me just confirm that. Negative 3, negative 1, 3, and 9. All right? Your first differences, the first difference is 2, okay? Now, 3 plus 1, that's 4. Now, this is 6, and this is 2, that's 2. Now, this is your A plus B plus C, okay? All right? Now, your first term of the first difference is 3A plus B, and your second difference is your 2A, right? So now, therefore, you can work out what A is. So you have 2A is 2, then A is 1. Now, you can substitute 1 in this. You've got 3 bracket 1 plus B. That gives us minus 2. So B is minus 2 minus 3, which is, okay, wait a second. We just check here at the back. Okay, Abram, do you have anything to say to them?
Yes, I have some questions, and
Okay.
mindsetters are also trying out the challenge question. I like that. Actually, there's a comment from Lunga Matlati. He says, I'm even competing with my mom with the challenge question. Lol, wow, nice one, mindsetters. And also, mindsetter, if you're sitting there at home, try it out with your friends, because it's a cool challenge question. I'm sure you'll find it easy and you'll find it interesting. It's posted on facebook.com/learnextra. Make sure that you go to that page. And currently, we are sitting at 69,500 likes. So we need about 500 more mindsetters to get to 70,000. So get all your friends and your classmates to like our Facebook page. It's facebook.com/learnextra. Back to you, Sifia.
Okay, thank you. We move on to the next question because of time, guys. So you've got your, the sequence that I want you to try at home is the sequence 3, 9, 17, 27. We are told that it forms a quadratic sequence. You need to write down the next term. That's the first thing. And the next one, if Tn is an squared plus bn plus c, find the values of A, B, and C. Can you still do that one? That other question?
I think we should take an ad break and then we'll deal with it after the break.
Okay.
Or we
Right.
can just finish.
Right,
Grace.
whichever way. So we've got that. Now, I was still explaining here, you've got your 2A, it's equals to 2, right? So we know that the second difference Okay, A is half the second difference. So if our second difference is 2, all right, then our A is 1. All right? Now, we know that for our first term of the first difference, which is, in this case, you have -1 plus 3, that is 2. So it means that our B is -1. And after getting the -1, so you've got your A plus B plus C equals to our first term, which is -3. So our first term is -3. The value of A is 1, plus the B is -1, plus C, which gives us -3. Therefore, C is -3. So you write it in the form of an squared plus bn plus c. So Tn equals to an squared plus bn plus c. So A, we worked it out, it's 1. So you sub in 1, you get 1n squared. So this is n squared. And your B is -1, so minus n. And your C is -3. So your Tn will be n squared minus n. It's n squared minus n minus 3, which is exactly the same as what we got there. Okay.
We've come to the end of our show. Thank you so much, Mindsetters, for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get your notes and to watch the videos from the term. Goodbye.